first thing you have to consider before you really look at cosecant is what's the relationship between sine and cosecant. And I hope that you remember that the relationship between those two is that they are reciprocals. Now, when you look at the graph, I have y equals sine of x graphed on here as just a really light dotted orange curve. What I wanted you to be able to do is sort of take a look at some of the relationships that you can see. So, first of all, if you identify any of the places where your sine curve would have had an x-intercept, so like here, or here, or here, and so on, those are now your asymptotes. So let's just since we're there, let's go ahead and identify those asymptotes. Now I asked you to identify at least 3. So I could say x equals 0, x equals pi, and so on. These are separated by pi units. So my generic asymptote will be x equals plus or minus pi times some number n. All right, next up, if I look at the sine graph and compare it to the cosecant graph, the next thing I can kind of take a look at here is that the high points and low points of my sine curve become sort of the vertices of these parabola-ish shapes. So we don't really have any x-intercepts or y-intercepts in this case, okay? But we can talk about some of the other features that we looked at in the other functions as well. So, for example, let's look at the midline. So the midline of the curve, once again, is in the same place it has been on the other functions. It's at y equals 0. The amplitude, this is again sort of a trick question. Now I want to explain. There really isn't an amplitude, so the technical answer here would be there is none. However, if you wanted to talk about how far those vertices were from the midline, then we could go back and say, oh, maybe we could call that a 1. All right, so you could really use either one of those answers, and I would be okay with that. And then finally, period of the function. So in order to really get an idea of the period of the function, we have to look at getting both of these sort of parabola-ish shapes, one that points up and one that points down. So let's see here. If I go and look at this parabola-ish shape and this parabola-ish shape, I'm going to get both of these. Now, to mark the beginning and end of the period, guys, I could mark, sorry about that, the beginning of the period, I said with green, let me get a green color here, with this is at my asymptote, right? That's the beginning of the period, this asymptote. And then the end of this period would be here at this other asymptote. Now, if I look at how far apart those two things are, I go from negative pi to positive pi. That's a total length of 2 pi.